All right, welcome back. Today we're going to continue where we left off with classes in Java as kind of our transition over to object-oriented programming in Java. Remember that we are online here with question and answer, live Q&A with Piazza. So if you've got a question online, go ahead and please post there. Otherwise, let me lift this up a little bit. There we go. Otherwise, before we continue with what we were doing last time, I want to remind you that, of course, your first assignment is due this Friday. And according to my Gantt chart here, I've done about 70% of the grading on Lab 3, so I'm going to mark that down as 70%. Hopefully, you're 100% there. Grades, of course, we'll post later today. I've already marked us down as 100% on a rough draft on the two exercises that I've been going through over the last couple of weeks here. And we are past the debug factor cleanup phase, but I'm not done, at least with those two exercises. So I am behind, right? This is today, and I'm behind over here. Note here that you have about 36 hours to catch up and make sure that everything is in by midnight on Friday. This is 10% of your grade. It's 100 points. We'll show you how we end up grading if you've never taken a course from me before. We'll end up pushing everything to something called code post and then letting you know once we're done grading. Generally, it will take us until next Thursday to grade because we do it with 48 hours for the initial grading and then an additional 48 hours for the course leaders to do some double checks on everything to make sure that everything is correct. So make sure that you are using the next 36 hours to play catch up or just to put those final finishing touches on it. Ideally, that's where you are right now. Okay? So I'm going to go ahead and save that and get rid of it. Remember that last time we were working on this other exercise, half-life, and that was motivating our design of this object over here, of this class. That we called it an isotope, and then we said that, well, there are these 5 things that are associated with an isotope: an atomic number, an element name, strontium, an element symbol, SR, the half-life, 28.9 years for it to decay into its decay elements, or into its decay isotopes, and of course an initial mass, because we want to measure how many years until we get down to 50% of it that it was before, but we want to build this table basically. We want to build this decay table right here. So if we started out with 10 grams of strontium, then about 29 years later, we would have about 4.99 grams left. Of course, with some other radioactive products still there, decay products. Before we continue, though, here, and what we were working on at the very end last time was creating, through what's called a constructor, creating an isotope instance. What I want to take stock of what we've covered so far and put these into our notes here, okay? So remember that Java is a class-based, object-oriented programming language. Right? That means that everything in Java is either a class, right, or it belongs to a class. And for the most part, the functions that you've been writing, especially the main functions, that simply means that you have to locate them in a class. It's not like C or Python or MATLAB where you can just start doing things and you can create a function and it has global scope and it's just a function, right? That function has to belong to a class in Java, okay? I don't know if this is large enough. Let's go ahead and zoom in a little bit more. There we go. All right. Well, what is a class? A class is basically a class in Java, I should say. Allows you to group, I'll emphasize that, group multiple pieces of data together into one logical unit. All right, this is just one aspect of it, and this is called encapsulation. This is something that we'll cover a little bit more in detail as we get into object-oriented programming more formally. Right, and it is essentially a blueprint for creating instances of the class, right? So for example, in our example that we've been designing so far, the class itself is called isotope, right? That's just a general concept. That's a blueprint. There are many, many isotopes. For example, there's strontium-90. There's uranium-235. These are actual instances of this class. The class serves as a blueprint for creating these things. And I think blueprint is one word, isn't it? Okay, my spell checker says so. It's a blueprint for creating these instances. And then you can create as many instances as you want. Each instance has its own member variables, or member variable values, right? In other words, the half-life of strontium-90 is 28.9 years, is not the same thing as the half-life for uranium-235, which is 700 million years, right? Each one of them has their own pieces of data, has their own copies. So even though we only have one blueprint and there's only one variable named atomic number, each instance gets its own variable named atomic number, right? And this is very, very similar to in C. You have in C and MATLAB you have structures. In Python you also have classes, and they have member variables, right? To create instances of a class, right? You instantiate them using a constructor, right? A special method that specifies how an object, an instance, is created or initialized, right? And the new keyword. Right? The new keyword is a special keyword that invokes a particular constructor. Okay. Now let's go ahead and go back to what we were working on. And then we'll come back as we go along and add some more observations that we make as we start doing this, okay? So this is a constructor. The constructor has a very special name. The name has to match the class name. There is no return type because implicitly you are creating an isotope, so it returns an isotope instance. You can make it public, private, protected, or whatever. We'll come back to that later on as well, okay? But otherwise, it takes an atomic number, an element name, element symbol, half-life, and mass, right? And what we were doing last time is that we observed that this actually had no effect. And it was because of all these warnings right here that I'm trying to set atomic number to atomic number. Wait a second, there are two atomic number variables here. There is the parameter variable, and then there's the actual member variable up here. And so what I'm doing on line 31 and beyond there is basically what I've done on line 28 and 29. If I create an integer, a variable x, and then I set x equal to x, that's perfectly valid, but all you're doing is taking the value out of the variable and putting it right back in the variable, resulting in the exact same warning that the assignment variable x has no effect. Right? This is dead code. Why would you do this? Likewise, this is dead code because what you're doing is you're setting the parameter variable equal to itself. Right? I need a way to distinguish. Are you talking about this atomic number or are you talking about this atomic number? Okay. And I shouldn't have gone in that order. Are you talking about this, or are you talking about the parameter atomic number, or are you talking about this object's atomic number? And of course, I want to set this object's atomic number to that parameter variable. Right? So the keyword that I do to that, use to do that is the word I was emphasizing, this. Right? This atomic number is equal to the parameter variable atomic number. In fact, if I hold down command and I can click, things become clickable in Eclipse, and if I click on this, it'll actually take me up to this parameter variable. It knows that this is referring to the parameter variable. If I click on this atomic number, it takes me up to the member variable because it knows that that's referring to the instance's atomic number. Okay? All right, I need to do the same thing with these other four. So I could set type, or I could look for a shortcut and type all that at once. Right? Or I could have copy-pasted, whatever. Remember, that's a trick. That's a code block selection mode. And at least on a Mac, it's going to be Option Command A. It's probably going to be Alt Command A on a Windows machine, but you'll have to check that out for sure. Okay. Now that I've got, now that I'm properly assigning these variables, let's go back to my demo over here and see that strontium-90 should have an atomic number of 38. Uranium-235 should have an atomic number of 92. Remember last time when we ran this, it was giving me 0 because I was not properly initializing those variables. Now I am, and it's printing out 38 and 92 appropriately. Okay? All right. Just checking for any questions online here. Remember, we are on Piazza if you've got any questions. Otherwise, great. Now it works. Okay? Let's go back over here to isotope. And no, let's go back over here to demo, and let's make some observations here. I created the strontium-90 isotope, and I set its atomic number here to 38. Okay. What if later on in the program I say strontium-90 dot atomic number? Or let's change its half-life. Right. Half-life. Now normally the half-life is 28.9 years. We'll go ahead and say I've got a lot of nuclear waste here. I need to get rid of it. So let's just go ahead and change its half-life to, I don't know, 1 year. Right? Now, first of all, physics, is that possible? Can you change the fundamental constants of physics and change something's half-life? You could technically, I guess, if you irradiated it even more into other elements, but then that are even less stable and would have a quicker decay product. Maybe, I don't know. I'm not a physicist, but no, you cannot generally do this. You certainly can't do this with one line of code in your nuclear reactor or whatever you're doing. So it doesn't seem like this is something I should be able to do. In fact, here's another even worse thing. What if I set it equal to negative 10 years? Does that sound like valid data? Can you have I mean, you can have a half-life of 0 if it's non-radioactive isotope, but otherwise if it's a stable element, it stays as it is, right? A half-life cannot be negative. That would be like saying that it's going to be it's radioactive, and it becomes radioactive as you go along. It becomes more and more radioactive as you go along. That's not how it works, right? So I want to close off the outside world from making any changes to this stuff. So let me go back over to this isotope class here. And I'm going to go ahead and make half-life into a private variable. Before it was actually, the absence of any keywords here makes it package protected, which we won't get into in too much detail. But essentially, you can make it into a public variable, into a protected variable, which is something that we'll talk about later with inheritance. But right now, I just want to focus on public versus private. Right? Now, if I make something public, then anything can see it, anything can change it, like I'm doing right here. But if I make it private, strontium-90.mass, I'll make that into, I don't know, 0. Right? Before we started out with 10 grams in the constructor up here, and then I'll set it down to 0 over here. A public variable can be seen by anybody, including outside the class. But a private variable can only be seen inside the class. And if you can only see, we do call these things visibility. If anything can see it, anything can change it. And if anything can change it, then you've got chaos. Right? Now, any piece of code can change the value in any other piece of code. In other words, it makes all of your variables into global variables, and globals are evil. Why? Because if anything can change a variable, then then you have to test for the eventuality that everything will change that variable. And if you're doing that for every single variable everywhere, you have what's called localization. In general, you want to keep the changes in your program scoped down as little as possible. That's why when you write a for loop, right, you can write a for loop like this: int I equals 0, for I equals 0, I is less than 10, I plus plus. And you can do whatever you want with your I variable right here. But even after the loop, you still have that variable I hanging out there, right? Versus the proper way of doing this is to scope down your variable only to that function. So that, or only to that snippet of code, to that loop, or to the function that you're talking about, or in this case, as we're getting into object-oriented programming, scoping it down to just that class, and so only that class has to worry about that variable. Here, once we've scoped it down to only this for loop here, then it doesn't exist outside here. We've scoped it down only where it needs to be. Things should only exist where they belong, right? We don't want chaos where everything can change anything else, and so we have no way of controlling anything, right? And in other words, we have to do tests on everything. What happens when somebody sets a mass to -10 grams, right? How do we prevent that? Well, we can't right now because this is a public variable, or sorry, we can with mass because that won't even compile. But we can't do that with half-life because we've made it into a public variable. So let me go back over here and change all of these to private variables. Right? And again, my trick here, there, all done. Right? I've made them all into private variables. Now that has a consequence over here. First of all, I've solved the problem that I set out to solve. In other words, I'm closing off the outside world. You can't change this, all right? You can set it up here in a constructor when you create this thing, but later on you can't change your mind and suddenly say that the half-life is only 1 year now, right? I've made it basically what's called immutable, and we'll come back to that here in a second. Right? Any advice for using count variables in our classes? Not sure what you mean by count variables. My guess is that you're referring to the third exercise where you want to count up the number of games according to a publisher or something like that. And if you created a game class, that represents one game. It shouldn't know about all those other games, right, that the publisher has. So maybe you've got the wrong data modeling. Maybe you want a publisher class. That'd be going too far in my advice. But you probably want to handle that outside of your class. If you've got a list of games and a map that maps publishers to that list of games, then all you have to do is ask how big is this list, right? And that's where what I would suggest that you go with as a correct data model. Okay. All right. So back to this though. So I've solved that problem of closing off the outside world. Nobody can make changes to this after it's been created. But the problem is, now nobody can see it, right? Now I want to print out the atomic number. I'm not going to change it. I just want to print it out so that the user can see what they're doing. Otherwise, there's really nothing to do with these objects, right? Strong TM90 dot. All I have access to is the things that are part of the language, which are equals, get class, hash code, notify, blah, 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 right? Those things are not very useful, okay? They're useful, but not immediately useful to what we're trying to do. So let me go back. I do really want to print out that atomic number. So my initial instinct, of course, is to make this public, right? But that's wrong, right? Again, I want to be able to limit the scope of changes in my program just to a class, a localization, right? All right, well, let me go ahead and create another method here that, oh, you want my atomic number? Okay, here you go. I'll go ahead and give it to you. And public string, the atomic number is an integer, int, get atomic number. And I will simply return this object's atomic number. This dot atomic number. Okay? Now, in this instance, I don't technically need the this keyword. Why? Because up here, I was having a problem because there were two variables called atomic number. Atomic number in the parameter list, and then this atomic number. Down here, there are no parameters, so there's no ambiguity. So it knows that, oh, atomic number, you must be talking about this object's atomic number. Right? But it's still best practice to do this. Right? Just use this keyword so that you don't confuse yourself. It's also if you're getting into the practice of having consistent code and consistently styled code is an absolutely valuable skill. And so if I use this up here in the constructor, I should be using this down here in this. This is called a getter, right? Why is it called a getter? Because it simply gets the data in the class, okay? All right, well, I also want to print out, now it's no longer atomic number, it's dot get atomic number. That's a method, right? Note here that I have to call it because it's basically a function. So I have to provide the parentheses there because I'm invoking that function. Likewise, get atomic number. And now it'll work just like it worked before. Right? All right, let's go back, and maybe I would want to do this with the element name. Maybe I would want to do this with the element symbol, et cetera, et cetera. So I've got a lot of typing to do, right? Nope. You can't see it because this my main screen is on another screen right now, but if you go up to source and then generate getters and setters, you will get a dialog box that looks something like this. Let me go ahead and expand these out. First of all, it already recognizes that the atomic number has a getter, right? It's right there. And so it's not going to generate that. But I'll go ahead and select all the getters. Say generate, and it did all my typing for me. Note here that it didn't use the same, that might have been an option that I didn't select there. But of course I can go ahead and go through and fix that auto-generated code, okay? Now, another thing that it didn't generate is documentation. This method returns this object's atomic number. Right? What is the documentation going to look like for get element name? This method returns this object's element name. This repeat, repeat, repeat. These are trivial methods. They don't need documentation, at least for this class. If I were doing this in, say, industry, I probably would generate, I would probably document these, but I would set up my IDE to generate that documentation, that default documentation for me. Getters are trivial methods. Right? I know what that does. It gets the atomic number. It gets that element name, right? It's in the name of the function. It's in the name of the method. That's self-documenting code. You don't need to document that any further because it does what it says on the box. Right? There's no need to document that, okay? All right. Well, maybe I really do want to reset that value. For example, you know, the atomic number doesn't change, the name doesn't change, the symbol doesn't change, the half-life doesn't change, but what does change? The amount, the mass, right? As we go along in time, that mass will decay. So maybe I do want a setter on the mass, right? Let's go ahead and do it over here. And again, I'm going to go to source, generate getters and setters. And I'll go ahead and, oh, not that one, but I just want to be judicious about this. I only want the one for the mass, okay? And I'll generate that. Right? And now we've got a getter and we've got a setter for the mass. Let's go back over here and reset it. So it's been 28.9 years. Now my strontium 90 dot set mass. Now I've only got like 5 grams instead. Okay, and let me go ahead and print that out to make. Oops. Copy. Let me go ahead and print that out to make sure that it works. In fact, I'm going to go ahead and get rid of that entirely, and I'll say that there's the mass. Oh, and then it's not the atomic number. Mass is. And then after I've decayed a little bit here, now mass is, and then we'll get the mass again. So again, it started out as 10 grams, and then it decayed, and now it's at 5 grams, right? And you see that right there. Atomic number, the mass is 10 grams, and now it's 5 grams. I've made that into what's called a mutable object. Remember when we talked about strings, I said that strings were immutable? Once you create it, you cannot change it. You would have to create a brand new string with different values. The uppercase h instead of the lowercase h, right? In the string hello. Likewise, initially, my isotope here, once created, only if everything is private and you can only access things through getters, then it also made it immutable. What I've done by creating a setter here is I have made it so that my class is now mutable, that you can actually change it, right? Maybe that's a good thing, maybe that's a bad thing. I don't know. It's a design question, right? Do you absolutely need a mutable isotope? Well, if you absolutely need a mutable string, then go ahead and use a string builder. If you otherwise, this string over here, this is immutable for a reason, right? For a very good reason. We like immutability in general because if nothing can change it, then it is automatically thread safe. What I've done here is I've made this thread unsafe, but that's okay for now, right? This is not the best way of doing it, but I will show you an advantage to doing it like this. We said before that you can't have mass that's negative, right? Now we can localize and do our do some data validation. If if the mass is less than 0, then I can say that's an error. You can't do that. Right? I could throw a runtime exception, but what I'm going to do is I'm going to throw a new illegal argument exception, which is a runtime exception, but it's just a it's just a custom message here. Mass cannot be set to 0, or set to less than 0. Right? So that if I try to set it to less than 0 over here, say -5 grams, that's going to result in an error. Nope, you can't do that. That's bad data. I'm validating the data. This is only possible by controlling everything through getters and setters. If you just make everything public, now it's chaos. Now it's the Wild West. Anything can set it. Anything can set it to any value that they want. Okay. Why we can't use a constructor in program 3, correct? Since we'd have to make a separate class, and we're only supposed to turn in the 3 source files that we were given. Good question. And you can make whatever classes you want. You just need at least the 3 that we've specified. If you create a game class, you can go ahead and hand that in. It'll still work. It needs to compile, of course, but it just compiles every single Java file that you hand in, and it runs them. Right? So yes, you can do a separate class if you want. In fact, do it if you are going to go that way. Do it as a separate class. Do not make what's called an inner class. You can have a class inside of a class inside of a class inside of a class if you really want. Public class sub-isotope. I don't know, that sounds Star Trek-y. Is there such a thing as a sub-isotope? Public class sub-isotope. Right? And you can continue doing this. These are called inner classes. They have a use, but certainly not this use. Right? And that's probably not what you want to do. A game should not be like an inner class to a game report. Okay? But there are a couple of instances that it does turn out to be useful. Let me go back over here to demo and reset this so that we're not throwing that exception, and see again that that it's correct. Right? It doesn't throw that exception because I properly set it to a valid value. But again, this is only possible if you allow control through getters and setters. And here I'm not allowing any control on, say, half-life because I don't want you to change it. I want that particular field, that particular variable to be immutable. You cannot change it. Okay? All right. So let's observe a few things here. Right. Constructors are used to specify how to create objects, right? And under that, actually, let me rewind a little bit to Tuesday. Remember that everything worked before we even started typing this code, right? Let me go ahead and get rid of that. Right? Do you see a constructor here at all anymore now that I've gotten rid of it? Nope. But it still worked. It's not going to work over here because once I save this, it's going to say, I don't know about this 5-argument constructor over here. But it does know about a 0-argument constructor if I took those away. That's what we started out with on Tuesday. That's called the default no-argument constructor. By default, a no-argument default constructor is provided by Java. Right? It simply just sets up memory for you, basically. You don't have to worry about memory management in Java, so you don't have to say that, oh, okay, like you would in, say, if you're coming from a C background, whenever we created an instance of a structure, we had to use size of structure, and then we had to call malloc because we need, say, over here, we need 4 bytes for that atomic number because all integers take 4 bytes. We need another 4 bytes for a string because that's a reference, and so we need 4 bytes for that, 4 bytes for that. That's actually 8 bytes. That's actually 8 bytes. So 16 plus 24 bytes. That's how many bytes we need. We don't have to worry about that in Java, right? And the constructor, the no argument default constructor provided by Java, takes care of that for you. However, the moment you define your own constructor, the default constructor goes away, right? That it's no longer there. If I take away all of these parameters, of course I can use that no default or that no argument default constructor because it exists. But the second that I define my own constructor here, then it goes away. Now this is a compiler error, and this one is compiling. That's okay, because you can define as many constructors as you want. Let me go ahead and restore that default no argument constructor. Isotope, by providing to do, right? Like any good programmer, if you don't want to do it right now, you want to go and play a few rounds of whatever video games you do, fine. Remember that you have to use that to do, and then of course down here in Eclipse, you can keep track of all of your to-dos. Right? I've got a lot that I need to do apparently. Right? Okay, and I've got a lot of problems too. I've got 69 errors, 148 warnings, and 0 other problems. I was hoping that that would come out to 99. Right? But anyway, I've restored the default no argument constructor. Everything over here now compiles. You can define as many constructors as you want. For example, let me go ahead and get rid of this one. What if I wanted to define an isotope, but I don't know what its initial mass is? I just want the concept of an isotope. I've got strontium-90, the idea of strontium-90, rather than 5 grams of strontium-90 or 10 grams of strontium-90. Well, I can't do that right now because I've got this constructor right here. I have to provide all 5 of those things. What I would like to do is, what I would like to do is to have a constructor that creates strontium-90 without an initial mass, because I'll go ahead and worry about that later. Right? All right, you can do that. Let me go ahead and create another constructor, but instead of providing all 5 of those values, I'll only provide those 4. Okay? Now, what about mass? Well, mass is a double, so I have to set it to a value. If I don't set it to a value, by default, numbers will have a 0 value default. Right? Numbers will have a 0. So, in other words, explicitly doing this, mass is equal to 0.0. That's basically what Java is doing for me by not having this line here at all. It's better to be more intentional, though. Don't just rely on Java to do all your work for you. Go ahead and put that in and say, yes, I meant to set that equal to negative, or to a 0, right? A 0 mass. Right? Problem, though, is I've got a lot of repeated code here, right? I've got, I mean, this isn't an exact repeat. The first 4 things are a repeat of this. I've got repeated documentation, certainly, and I've got repeated, this code chunk here is basically this code chunk here, but only replacing that with a 0.0. Don't repeat yourself. The DRY principle, the dry principle. If you can have a function call another function and do its work for you, then you do that. These are methods, and you can have them call each other. So if I'm only given these 4 things, I could call this up here, or conversely, I could, if I'm given all 5 things, could I call this one down here? You gave me 5 things, and then I hand off the work to something that only takes 4? That doesn't sound right. If you gave me 4 things, though, and I know what the default value is, 0, then I can hand that off to the thing that takes 5 things. So let's do that. I want to call that constructor and simply just pass in all those values. Atomic number, element, name, element, symbol. Lots of typing, right? And the mass, of course, there is no mass here, so I'm just going to have to put in that default value that I wanted of 0. Ooh, how do I call that constructor up there? I could call isotope. How do you call constructors? New isotope. That doesn't really work. That's not going to have any effect, actually. It's going to compile. I'm actually a little bit surprised that it compiles, but that's not how you do that. Right? How does an object refer to itself? This, me, I, self, right? Except that it's an object, not a person. So we're not going to anthropomorphize it and say that me, myself, I, right? Some languages do that. I think VB uses me. Somebody asked on Tuesday, what about Python and self? Yes, but we use the this keyword. Why? Because it's just an object. We don't want to treat it like a person, right? It's just a thing. So we will objectify it, right? And we use the this keyword. This, when used without a dot, is going to refer to another constructor. In fact, if I highlight this, it'll take me right there to that constructor. Highlight it and click it. And now I don't have as much repeated code. Again, constructors are kind of trivial methods that don't need documentation in my eye, or in my mind, at least not manual documentation. Certainly there should be auto-generated documentation. That was a lot of typing, right? I screwed up. Or I didn't want to type all that stuff to begin with. Guess what? Source. Generate constructor using fields. All that work is restored. Source. Generate constructor using fields. I don't want that mass. Right? And I should, there, I can generate my own comments there. I'll just go ahead and click that from now on. Omit call the super, yeah, you can do that or not. Unfortunately, it's not going to call that other one, but let's go ahead and see what it does. Ooh, nice. Now, it doesn't actually generate, the words, but you can change your own templates in Eclipse so that it would put in some default text there, right? So, no, you don't have to type huge amounts. I'll go ahead and undo that and restore what I did type, though. In fact, under source, there are lots of other shortcuts. You can generate generate getters and setters. You can generate a two-string method that we'll do here in a second. You can generate constructors. You can generate a whole bunch of other boilerplate kind of code. All right. Question online here. Is creating a game class the best way to approach program 3 on assignment 1? It's a way. It's equally easy to use a map and strings. It's half of one, or what is it? What is the expression? 6 of one, half a dozen of another, right? So yeah, you can create a game class if you want. It's not expected. I'm not going to say that it's the best way. I'm not going to say that it's the worst way. There are certainly bad ways of doing the assignment. But creating a game class and using it is a good way. It's not the only good way. Right? You can use smart data structures like maps, lists, and just use strings. Okay. Certainly for your project, you're going to be creating objects, though. You're going to be creating classes. But anyway, back to the task at hand here. So that will have a default value of 0. That's okay. I can set it later to 5, and you'll see here that atomic number 38. The mass was initially 0 because I called that 4-argument constructor, and now the mass is 5 because of the setter on line 26. Good. So the moment you define your own constructor, the default constructor goes away. You can define and implement as many constructors as you want. In general, constructors should call other constructors instead of repeating code. The dry principle, right? Principle, right? Do not repeat yourself. Or I guess it'd have to be don't repeat yourself, because do not DNRY principle. No, DNRY. That's something I can't think of what it would be right now. So in general, constructors can call other should call other constructors, and you can easily generate both getters and setters in your code using your IDE. Right? Eclipse or any IDE, IntelliJ is going to be able to generate this kind of stuff for you. Rudimentary ones, maybe like BlueJ or something like that. People have asked about that before. Probably not sophisticated enough to do that kind of stuff. Okay. All right. Another thing that we've observed is, in general, you should limit the scope of variables. Right. This limits the possible changes in your program. Right? Thus, in general, your variables should all be private. Right? So nothing outside your class can access or change them. Right? This makes it, this can make it immutable. Right? You can then control access through getters and setters. And again, you can automatically generate those things. You can generally auto-generate this boilerplate code. Right? And it doesn't need documentation. Those are trivial methods. All right, well, I've talked a lot about just designing our object. Are we anywhere closer to actually solving this problem of generating this table? Nope. So let's actually do that now, right? What I'm going to do is I'm going to get rid of this other stuff that I've been demonstrating, this cruft, right? This extra code that's not doing anything. And let me go ahead and restore this 10-gram isotope of strontium. I want to generate this table. So ideas. Well, first of all, let's read the handout here because it gives us some formulas, right? The amount can be computed, so the amount that you have left over after so many years can be computed using this formula right here, where m is the initial mass, or the current mass. So if you just look at it right now, and then 1 year from now, it's going to have less mass. So the initial mass, whatever your timetable is, you're going to be looking at that beyond, right? Times, C is this number right here. That's just a, I think it's e to, I think that you could get away with like 1/2 there. Isn't that just 1/2? Anyone want to pull out their calculator and tell me? Wolfram alpha exp of, I've got a calculator right here, negative 0.63 or 693. There we go. Yeah, it's just 1/2. Why would it be 1/2? Half-life. Duh, right? But we make it a little bit more complicated here so that you have to call the math library, right? So this is just a constant. If you want to use that, if you pull out your calculator and realize that, hey, that's just 0.5, fine, go ahead. 0.5 raised to the number of years divided by the half-life. So that once you hit that half-life, h over h, that's 1. And so now C becomes 0.5, and what do you have after the half-life? You have 1/2 the original mass, right? Neat how that works out, right? It's just math. So let's go ahead and, but this one was a while loop. We want to go from year 1, or not a while loop. We'll go ahead and go into we could go into a while loop if we really wanted to, but I'll just go ahead and go with for loop here for each year, right? For int I equals 1, I is less than or equal to 29, I plus plus. Right? That's not the exact assignment that I assigned. It would be more appropriate to do a while loop here because you have to go until you're out of the isotope. But here I'm just going to hard code this to 29 so that we can, because this is not the focus. Object-oriented programming is the focus. All right. So I'll say let's go ahead and have a double current mass. Right? And what should I initially set that equal to? Well, 10, because that's what I set it equal to up here. But I could go ahead and grab that out of the isotope. Dot get mass. There we go. So there's the current mass. We start out with 10 grams of strontium here. Now after year 1, in fact, that's okay for a normal loop. Maybe though, since it represents a year 1, year 2, year 3, maybe I want to call that something else. What should we call that? We could go year. We could be short for Y. because that's what's in our equation up here, right? What do we want to do? Leave it as I? Okay, we'll leave it as I. I wanted to show you the trick though. Hopefully, I think I might have shown this trick before. If you want to rename something, you refactor, rename, and all instances of it will be renamed. Right. Okay, I'll just go ahead and keep it year now. Right. All right, so how much do I have after that? After year? Well, that's this equation right here, right? So current mass is, or mass is equal to the initial mass, which is unchanged in that isotope up there, a strontium 90, and then multiplied by 0.5 raised to the year divided by the half-life, right? It's times 0.5 raised to the year divided by the half-life. Right. Now that is nowhere near valid Java code, but I wrote it out so that I can then go through and replace those things with valid Java code. Remember, and I've closed my Gantt chart now, but remember, you code iteratively. You create an initial first draft, and then you go back and you change that second to that first draft. Maybe you don't do it as direct code here because it doesn't compile, but you do it as a comment or something like that. And then you come back and you fix it. So first of all, that's not the half-life. The half-life of strontium is 28.9. Should I do it like that? No. Let's use strontium 90's value for half-life. Okay. Getting closer. Probably want some parentheses right here because it's raised to that value. Some languages support that. Not Java. Java does support that, but that's the bitwise exclusive OR operator, which has nothing to do with what we're trying to do right now. So how do I raise x raised to the y? How do I do it in other languages? C, how do I do x raised to the power of y? POW in the math library. How do I do that in, here's a good question. How do I do that in Python? I think Python does support that. I'm not sure though. Anybody online can tell us? In Python? Okay, but it has some POW function there. That makes sense. Why? Because Python is written in C, and it's just accessing the standard math library under the hood, right? So here, though, we have math, capital M, dot, POW, 0.5 raised to the year divided by that half-life. And I just need to make sure that I balance my parentheses, okay? That's the current mass. Now all I have to do is print it out, system.out.println, year plus, I'll tab over or something, plus current mass. There we go. And let's see what this looks like initially at least. Nice. Doesn't look like that formatting though. There's no gram. It goes out all the way to, it goes out a whole bunch of decimal places. You see that it starts to get misaligned when I get to 2 digits there. Well, actually it's not getting misaligned in this case, but some people have been asking, how do I align things? And you just use the printf style formatting. Right? So let me go ahead and do that for the year. The year is a integer, so %d. Right? And you also, by the way, you have this in Python too. Python, you just use the percent. Python 3 is the only thing that I will ever talk about. But in Python 3, you can have a formatting string and then a % and then a tuple with all the variables that you want to print formatted. Exact same placeholders. %d is going to be for integers. %f is going to be floating point numbers. And then you only want it out to 2 decimal places, 0.2 in front of it. And then you want to end the line, well, inside the string. Year and current mass. And you get it to look much closer to the expected output, right? We're not going to begrudge you if you go out 3 decimal places. In general, on the web grader especially, you only need to print out at least as much information. So it would be wrong to only print the most significant digit and say 99999 everywhere. But printing 3 digits, 4 digits, that's fine, right? Now, nothing's aligned there. I can easily align it by padding it out with, say, a minimum of 3 columns. And let's see what that looks like. Now everything is aligned. All that my decimals here are aligned. It's right aligned, right? So that a space and 1, there's actually 2 spaces there because I said I want a column size of a minimum of 3. So if it's only a 1-digit number, that's of course going to be space 1. Down here, it's only going to be space 10 because now it's a 2-digit number. If I exceed 3, then of course now it's going to be misaligned again. Right? But this is how you make tables or tableaus that are nicely aligned everywhere. If you want it aligned to the left, you provide a negative value. And now you'll see here that it looks slightly different. Everything's, that first column is aligned to the left. I wanted a G in there because there it represents grams. Go ahead and put that G in there. Right? I don't like that those spaces between there. I want more spaces or fewer spaces. Just 1 space, and that's good enough. Actually, there's going to be at least 1 space right here, but the other spaces are going to be because of the alignment of the first column. So print, if you've never seen it before, printf. But every language will have some printf capability. It comes from, C will have it, Python has it with the %sign. The way that I would do this is, in Python would be something like this. Percent. There. That's that's not valid Java, so it's not going to go file, but that's valid Java. Printf is supported in MATLAB, right? It just gets, you just have to learn the placeholders and the tricks, and you can magically make everything super nicely formatted all the time. Okay? Well, I'm satisfied with this. I'm going to go ahead and hand it in, make sure that it works. Right? We went all the way down to 4.9 here. Now I'm going to take off my practice hat and I'm going to put back on my object-oriented programming hat. Is there a better way of doing this? Who should know this kind of physics logic? Who should know about something like that? And when I say who, I mean what class should that belong in? Should that belong in the demo class over here? Or this kind of like, I'm asking a question of, given this isotope here with a mass of 5 or a mass of 10 grams, I want to say you decay yourself. And maybe it's not just, and again, maybe it's like 1 year, maybe it's 0.5 years instead of an integer here, right? I want to say if I waited 3 months or 0.25 years, how much of you are left, right? I want you to decay yourself. Right? The isotope decays. A demo program doesn't decay it. Right? In other words, this is behavior. I'm an isotope. I decay over time. So where should the logic for decaying, and where should the code for enabling that decay, where does it belong? It belongs to me, right? It's my responsibility. So let's go over here to the isotope and think about what that might look like. First of all, note here, as we're going to talk about encapsulation starting next week, that we've got the grouping of data. We've got 5 pieces of data that have been grouped into one logical unit. What else do we have? Methods. If you're coming from a C background or you've only ever seen structs in your life, this is completely different. Structs allow you to group data. They don't allow you to take a bunch of methods and throw them into the bowl with it. But object-oriented programming and Java does allow you to do that. I've got 2 constructors. I've got a bunch of getters and setters. There's nothing stopping me from making more methods to do whatever I want. Public. I don't know what the return value here is, but I will go ahead and decay. Right? Decay me, right? Should I call it decay me? Like drink me, Alice, drink me and eat me? No, I'll just call it decay. Right? I want you to decay, strong isotope. I want you to decay yourself by a certain, after a certain number of years. So what should the input to this function be, or to this method be? Okay, how many years? And do we always want to just go with just an integer? Okay, a double. Why? Because you know what? We want to support, 0.25 would be 3 months, right? Would it actually be 3 months? Are all months created equal? Nope, certainly not. It is not a leap year, so we've only got 28 days this month, right? Well, I can't think of the rhyme. 30 days has September, April, June, and November. All the rest have 31 except for February has 28, sometimes 29, right? So, definitely a double here, right? But that still doesn't seem satisfying. If I say 3 months, which 3 months? Not all months are created equal, right? It's not just simply a double. For now, I'm going to go ahead and keep it as a double, though, okay? What should the return value be here? I'm not going to return anything. Why? Because you told me to decay 1 year, say. I decay myself. I'm not going to give you anything back. Maybe I could design it so that I give you as however much I decayed, right? Or I could give you, I could design this, possible designs. We return how much is decayed, or decayed, right? Or return how much is left after the decay. Right? We could go one of those two ways. And what I'm going to do is I'm going to put a to-do here, because as I'm designing this object, I'm going to bounce these ideas off my partner, if I have a partner. Otherwise, if I don't have a partner, then I'll really think hard about getting one first. And then second, if I really decide not to have a partner, then I'm going to start talking to my duck on my screen. And if you've ever seen my computer, I do have ducks on my screen. Why do I have a duck sticker on my screen? Rubber duck debugging, right? Walk through it in your own head. If it means that you have to verbalize it to an inanimate duck up on your screen, you are doing rubber duck debugging. This is kind of rubber duck designing. Well, here's my first option, right? What are the advantages and disadvantages of that? Here, duck, I'm going to be the lawyer and I'm going to advocate for that. Duck, this is why I think we should do it this way. Or second one, duck, this is why I think we should do it this way. Or third one, return nothing. Right? So I'm going to go ahead and go with this one for now, but I'll leave the to-do in there because that's a design change that I can make later on. Okay? Decay, year. Okay? How do I decay myself? I have a current mass. Right? How much do I end up decaying? Right? I'm going to grab this over here and modify it. Right? So, do you know anything about strontium-90 in this class? In this Java class right here? Nope. I don't see any strontium-90 here at all. What do I see? I see an isotope. I see whatever I am, this. I'm going to get my mass. I'm going to multiply that by 5 raised to this year divided by this thing's half-life. That's the amount that I have left, right? So this is double remaining, right? And double decayed amount. Amount is equal to, well, how much did you actually decay? How many grams did you decay? Whatever you had before, get mass, minus whatever you have remaining. That's how much you decayed, right? And then I'll return. Okay, let's try this out. Let me go ahead and get rid of this for a second, because I want to focus on that method. Strontium 90 dot decay, and I'll go ahead and decay 28.9. Oh, what's half of that? 4, 5, 1, 4. I don't know what that's going to be. I do know what this is going to be. 28.9. Right? It's going to be 4.9, right? Or thereabouts. Right? So I'm going to decay myself, and then I'm going to print out how much I have left. System.out.println strontium 90.get mass. How much mass should now be left over? Right? Let's go ahead and print that out. It's still 10. I started with 10. I decayed 28.9 years, and I still have 10 grams of strontium 90. What was wrong? I didn't change anything, right? All I have here is two local variables. How I simulated the decay right here on line 71 and 72. That I went so many years, and that's how much I have now remaining, and this is the decayed amount. But I didn't do anything with them. Well, maybe I wanted to return them, or maybe I want to change myself. This dot mass should now be equal to however much is remaining. And now this is an unnecessary line here. This is technically unnecessary, but it's still best practice to do that. So in other words, I'm decaying myself, I'm changing myself. Let's go back over to the demo here and see that it now works. It's rounding up, right? It should be 4.99, but it's 5. 14.45 years, that's half the half-life. It's exponential decay, so it's not going to be 1/4, or it's not going to be like 75%. But it's going to be somewhere close there. 7 grams, right? It's going to be less than y. It's exponential decay, right? But 7.5 is a rough estimate. What if I went twice that? 28.9 times 2, because I don't want to do the math in my head. Java, you do it for me. Should I expect 0 now? Nope. Half is left over. Now I only have 5 grams. 28.9 more years means half of 5 grams means 2.5 grams. Half again, 28.9 years, 1 more year. All right. Then I'll have 1.25 grams left. How many years would I have to go to actually have 0? That's still not 0. 1,000 years? Yeah, technically you can't reach 0. Technically. Technically you can only get to the point where that radioactive is only a trace element, right? That it's no longer detectable. I mean, certainly there is a point at which, you know, that entire sample is decayed. I don't know how it works though, right? It's effectively decayed after so much. Right? There. So now, what I've done, now object-oriented program, take off your physicist hats. I'm not a physicist at all. This is just what I use to illustrate this here. Sometimes you use bank accounts, sometimes you use other types of objects. Let's see. Question online here. Can several classes be in one Java file? Like I demonstrated before, you can have inner classes, but otherwise, no. Everything has to be in its own file. Like I said, you can churn in multiple Java files though. Demo class with one main method and a class isotope with a constructor, getter, other methods. Will this will it still function in the proper way? Yes, this is functioning right here in my Eclipse. Yep. It will function in the WebGrader too, as long as you're following the instructions. Okay. All right, so I've taken off my physicist hat here, and I've put on my programmer hat. And what I've done here is I have made this object responsible for its own data, right? I have located the logic for decaying inside the class instead of outside the class. Right? That's very, very good. Now, let's go ahead and use it. Right? So I want to simulate the decay after so many years, okay? So I no longer have responsibility for saying, this expression right here. Instead, I'm telling the object, you decay yourself 1 year. Decay 1 year. I'm not going year. Why? Because in the first iteration, I would say decay 1 year. On the second iteration, I would say decay 2 years, and I don't want to do that. I want you to decay 1 year per iteration of this thing. Okay? And I no longer have current mass. I don't have to worry about current mass. I want to know strontium-90. What is your current mass after I've decayed you? Right? And we'll probably have to do this after that print statement because, oh no, sorry. Let's do it like this. There. Exact same table as before, but the design is different. The responsibility is now where it belongs. Isotopes should be responsible for isotope things, whatever that happens to be. A student class should only be responsible for student stuff. An exam class that simulates an exam or something should only be concerned with exam stuff. You shouldn't be getting your exam stuff and your student stuff mixed into the same class. You do that too much and you have what's called the God class, the God anti-pattern, where you've put everything and the kitchen sink into one class, and now it's responsible for everything. It knows everything, it sees everything, it does everything. It's omnipotent, omnipresent, omniscient, right? You don't want that. That's very, very bad coding. Where does the logic for decaying belong? It belongs inside the class. If I had a bank account class with a balance and an APR and an account owner and an account number, right? All that stuff should be inside the class, and I shouldn't have to rip open the class to figure anything out. Okay. Now, as our last thing for the day, let's think about those other possible designs there. First of all, do I need this variable? No, but I'll go ahead and get rid of it for now, maybe restore it later. This is one way of doing it. I've decayed myself, and then I have, and then I don't return anything. Let's go ahead and go with this design option then. What would that look like? Return how much is decayed. Public, double decay, double year. Right? Double, so I'm going to cut and paste this. And here I will restore that variable because I will decay myself, and then I will return what the decayed amount was. All right, now that I've done both designs, tell me which one is better. Which one do you want? They do the same thing, but one of them gives you more information than the other. So maybe that's you can always ignore the return value. Maybe that's an argument for this one. I like that. Let's document it. Decays this isotope by simulating the amount of time given in years, right? And returns the amount it has decayed. There. I like that. Can we have both of them? Java's telling me no. Why? They have the same name. They have the same input parameters, right? Now you can do something like, for example, if this were C, I can't have two functions with the same name, so what would I have to do? Decay and give me the amount decayed, right? And you think that's funny, but there are a whole bunch of, that's an anti-pattern, and it's also a common gripe against object-oriented programming paradigms that you have these class names that are a paragraph long because you have to describe them. Well, then you're doing it wrong, first of all. Second of all, there are lots of, generally stuff like that is auto-generated code that nobody has ever actually seen or maintaining. Mac iOS is notorious for this. They have all these Objective-C generated classes that are super, super long, and because they're named after variables concatenated with variables concatenated, and it's just so that it doesn't have any, conflicts. You can't have things with the same name. Now, in object-oriented programming, you can have methods with the same name. It's called function overloading. Right? In this case, though, it won't work because I'm taking the same inputs. If I called this, if I wanted the return value, which one would actually be called here? Let's go over here and look at decay. You're a dumb compiler, right? Okay, you're calling decay and you're giving me a double. I don't know which one you mean, right? Because ultimately you're not doing anything, but it's okay if you do something with it and store it into a variable. I'm not in this case, but a dumb compiler can't distinguish between those things. A dumb compiler is saying, which one of these things are you actually mean? Do you mean the one, this one, that doesn't return anything, or this one that does return something? So in this particular instance, we have to choose. So Sophie's choice here, which one do you want? This one's already documented, so. Okay. And I'll take out my to-do here. All right. One last observation here. Again, I want to go back to that year. What I want to do is, I want to do this monthly. Right? So, how many months in a year? 12. First of all, is that going to work? Java? 1 divided by 12 is what? Integer divided by integer is an integer. This is going to be 0. Don't decay at all, ever. Yeah, maintain your radioactivity. What would I have to do here? 1 divided by 12.0 at least. And then, there we go. That's 1 month. Is that actually 1 month, though? There's the first month, only 0.02 kilograms has decayed, then 0.02, et cetera, et cetera. Is that really, I mean, that's an estimate, but are all months created equally? No. So, what concept am I really going for here? I want you to decay yourself, not just in years, not just in seconds, not just in days or weeks. What's a catch-all idea for that? I want a way to represent time, right? So that I could say, I'll create this with 3 years, 4 days, and 27 hours. That would be 5 days and 3 hours, right? And 28.9 seconds, right? That's a time, right? Do you want to have the cognitive load to convert that to an exact number of days or an exact number of years? Probably not, right? So I want to think about that concept of time, right? What's a nice way of representing that? Class, exactly, right? This is what we're doing, right? Let me go ahead and create a time class. How would you end up representing this? Int years, okay. Int days, int hours, int minutes, int seconds, int microseconds. Right? Yeah, so I could do it this way with a series of integers and stuff like that. What's another way of representing time? Inside this class, let's just go ahead and stick with 1 unit. Say seconds, right? And so I could have int seconds. If you want fractional seconds, then you could do that as well, right? But you know what? I don't know. I don't like this at all. I don't like work. So, review, and this is where we'll pick it up here next time. Review. What the best engineers, if you're given a problem to solve, what's the very first question you should ask yourself? Is it already been solved? Class design. The very first very first question you should ask yourself is there already a class to do this for me? Right? And there is. There's a duration class in modern Java. Right? We'll get to that though next time. All right. Have a good weekend. Make sure that you are doing your homework. If you haven't started on it right now already, you are way behind. But hopefully you are to that point where we were talking about with that Gantt chart. All right. Otherwise, have a good weekend.